Okay, factoring polynomials. We're going to start with the greatest common factor. The greatest common factor is the largest polynomial that divides evenly into the polynomials. I'm going to illustrate this with our first example, 6x cubed y cubed plus 45 x squared y squared plus 21xy. So the largest polynomial that divides evenly into all of the polynomials. So numerically, if we're looking at 6, 45, and 21. 6, 45, and 21. We'll even do this maybe with a highlighter. 6, 45, and 21. What's the greatest number that goes into each one of those numbers? Well, the biggest number that goes into all of them is 3. So our greatest common factor numerically is 3. Put that right there. Then we have x cubed, x squared, and x to the first. The greatest number of x's that goes into all of them evenly is going to be x to the first. So it's an x, but it's the lowest exponent. So the lowest exponent they share. The lowest exponent the x's share. So now we'll come over here and do our y cubed, y squared, y to the first. Well, the lowest exponent they all share is a y to the first. So we've got x to the first, y to the first. 3xy is the greatest common factor. If I factor the greatest common factor out of the polynomial, I'm going to have a 3xy on the outside, and then we have to determine what goes inside. The easiest way to see what goes inside, and eventually, and you may already be there, it all depends on your skill level in math up to this point. The easiest way for me to see what goes inside the parentheses is for me to divide out the greatest common factor from each term. So if I divide the 3xy to the outside, so divide it to the outside, what I'm going to be left with is 2x squared y squared. The middle term will be positive 15xy, and our last term is a positive 7. So our answer is 3xy times the quantity 2x squared y squared plus 15xy plus 7. Now that 3xy on the outside of the parentheses is extremely important because what we created here was a product. We went from three terms to one term connected by multiplication. One term connected by multiplication. If I were to distribute that 3xy through to the three terms, I would get what I started with, which is 6x cubed y cubed plus 45x squared y squared plus 21xy. Okay, so let's try. Now this one's going to be interesting. X times b squared minus a plus 6 times b squared minus a. Now write that down and think, how many terms do you have and what do the terms have in common? How many terms do you have and what do the terms have in common? Go ahead and press pause if you want to try this on your own. If you want to listen to me work out the problem, just continue to hit play. Or continue watching. You don't have to hit play. You can just continue watching. Okay, what I have here is I have two terms. I have one term connected by multiplication, and I have a second term connected by multiplication. Both of those terms have a b squared minus a in common. So the GCF is b squared minus a. Now when I factor out b squared minus a, I'm going to be left with two terms. I'm going to be left with a term from the first term and a term from the second. We're stuck here. I'm going to bring it right back. Sorry about that. Sometimes that happens. So we're going to bring it right back, and we'll have a second term. Now what goes into that binomial? I've got x times b squared minus a plus 6 times b squared minus a. When I factor out the b squared minus a from each term, when I factor out the b squared minus a from each term, what I'm left with is x plus 6. So our answer is b squared minus a times x plus 6. And that is factoring out the greatest common factor. Let's do a few more factoring types of problems. We're going to factor trinomials. We'll factor all sorts of different trinomials.